what is this lesson all about? So basically, this whole module is about if you have these things called triangles, how do we solve for missing sides or missing angles? And when we have triangles, there's a couple of different types of triangles. I'll just draw some of the more common ones on the board. And the way we label triangles is we give the vertices capital letter names. I'm sure you all know this. So let's say like D, E, F, and let's call this P, Q, R. And so this first one, that would be like a right angle triangle. This one looks to me like an acute angle triangle. So all the angles are less than 90. And then this one over here would be an obtuse angle triangle. And so what we're going to try and do during this series is we're going to start with right angle triangles, and we're going to ask, if I give you some information, can you work out a missing side, or can you work out a missing angle? And the same thing will be true later in the series. We'll start to talk about not just right angle triangles. We'll talk about in acute angle triangles or obtuse angle triangles. If I give you some information, can you work out a missing angle, or can you work out a missing side? That's really what this whole module is about. Now, there are some other conventions that are important. When we talk about letters and small letters and big letters are normally reserved for angles, and little letters are reserved for sides. So opposite big A would be little a. Opposite big B would be little b. Opposite big C would be little c. So it does matter whether something is big or small in the world of triangles. So in DEF, this would be called side D. This would be called side E. That would be called side F. Give me a thumbs up in the chat if you've seen that notation before and you've seen different types of triangles like right angle triangles, acute, obtuse. I just want to check that you know about that stuff before we really get the show on the road. Okay, so this is the world that we're living in. And so we're going to quickly just check that you've got tools for your toolkit. So and the first tools I'm going to check are grade 9 tools. So if I gave you a question like this, could you find the unknown angles X, Y, and Z? So I want you to try and find the unknown angles X, Y, and Z using your knowledge of triangles from grade 9 and 10. And this looks to me like an acute angle triangle. There's no right angle in play, but I think you should be able to get most of these. So let's give it a go. What would X have to be? What rule or what tool do you know about from earlier grades? What do you know about that angle is the question. Yes. So X is 62 degrees because you know that angles on a straight line will always add up to 180. And so you know that that must be 62. Okay, so that's, you've used one of your tools. Now, what about Y and Z? Could you work out, given this drawing, what is Y and Z? What are those angles going to be? So what you notice is that this triangle here has two equal sides, and so what we know from grade 9 and grade 10 is that angles opposite equal sides are themselves equal. And so it looks to me like this angle over here is going to be 62. And we say y is 62 degrees. And the reason would be angles opposite equal sides. So basically, whenever you have a triangle, if you have two equal sides, the angles that are opposite those sides will also be equal. So this one is opposite this one is opposite that. And there's another variation of that which says if the two angles are equal, the sides will be equal. Okay, and what about Z? Okay, so Z makes use of the idea that in a triangle, all the interior angles add up to 180. And so Z would just be 180 minus 62 minus 62, or we'd say sum of angles in triangle. So what's that going to be? Okay, it looks to me like it's going to be 56 degrees. Let's just make sure. 120, yeah, 56 degrees. Okay, so that is an example of how we can solve for unknown angles using grade 9 and grade 10 tools. Give me a thumbs up if you feel okay with that. Give me a thumbs down if you feel a bit unsure. And then just take a screenshot if you need to before we move on. Okay. What if I said to you, let's do this one here. I want you to find me the size of angle, or not angle, sorry, length x. So length x is going to be this length here. And I want you, using your grade 9 and 10 knowledge, to find me the length of side x. Now, you might need to do a little bit of a step along the way, but let's just check that you and of course, don't worry. That's why we're here. We're here to help you. Why don't you start by working out what this angle is? Because if you work out what this angle, maybe that can help you figure out what x is. Abanejo, I agree, but let's just make sure we know why. So angle S is 25 degrees. And the reason that angle S is 25 is because of the sum of angles in a triangle. And if that is 25, that really helps us figure out what x is. Because isn't this opposite this one and this opposite that one? So what is x going to be? Well, I think it's going to be, because the angles are opposite, so the sides that are opposite equal angles, you're going to have to, x is going to have to be 2.2 centimeters. Because that's the only way these two angles could be equal to each other. So guys, this idea comes up a lot later in the chapter, that whenever we see isosceles triangles, if we know that two sides are equal, we know the two base angles are equal. However, if we know two angles are equal, then we know that the sides opposite them will be equal. And that's the rule we say sides opposite equal angles. So I just want to make sure that you've got that. All right. Maybe we should do another one like that. So if I say to you, what is the value of x? I know this is really straightforward, but it's important we get it right. What is b's value? What is x going to be in question B? It's the same idea. What is x going to have to be? Okay, it has to be exactly 1 point. So the 68 is opposite 1.5, and there's another 68 here, which means that this x is going to be 1.5 centimeters. And the reason is sides opposite equal angles. So in your toolkit now, you have a way of working out sides and you have a way of working out angles when you've got isosceles triangles. And that's the name for the triangle that has two equal sides. Okay, now another tool that can help you find unknown sides is something called Pythagoras. So I want to make sure that you know about this tool. And in order to make sure that you do, you're going to answer this question for me. So you're given a triangle with sides A, B, and C, and I want you to write down the theorem of Pythagoras or choose the right option from these four options. So go ahead and do that now. Okay. So with Pythagoras, you all know that the hypotenuse is the one that's going to stay by its or stand alone most of the time. So c squared and the other two sides, so it would be a squared plus b squared. And the correct option then is not going to be that one because it has to be c squared by itself. So it can only be b or d. And because you got the hypotenuse by itself, there's going to be a plus, which means the correct answer will be B. So the theorem of Pythagoras is really helpful in helping us to find unknown sides. And so B will be the answer for this. And so let's see if you guys can do a Pythagoras question just to get the brain flowing again. I want you to find me the value of x. Now, this is a right angle triangle, and so you have to find me this unknown side over here. Off we go. What's the length? What's the unknown side x going to be, given that we know it's a right angle triangle? So I see quite a few answers coming through. And you should indeed get 13 centimeters. Okay, now I want you to notice something. In this Pythagoras question, you were solving for the hypotenuse. However, sometimes they don't give you the two other sides. They give you, they give you different combinations. So let's just check that you can do Pythagoras in other combinations as well. So let's do this one. I want you to find the value of x in this right angle triangle for me. Okay, so ask yourself, when you apply the theorem of Pythagoras, which one is the hypotenuse? Some of you will know the shortcut. That's fine too. But basically, the theorem will say something like that. And then 49 minus 1 squared or 1, it's x squared There is a shortcut method to this, but so the square root of 48. So you should get 6.9 or 6.93 millimeters. Okay. All right, so that is another good tool. Let's do one more of these just to make sure that you know what's going on. So take a screenshot if you need to. And if there are any questions, don't be afraid to raise your hand. Let's do, let's do these two. So I want you to work out what B and C is, and then we'll move on from Pythagoras. Actually, no, we'll do one more after this. Let's see how it goes. So what's this going to be equal to? Okay, so that should be 25 centimeters. What about C? So in this one, we want to work out what that is. Now, sometimes there will be decimals, that's fine. And so all right, and so we get 5.19, and that would be centimeters. So 5.19 centimeters. So that is the traditional Pythagoras questions, and it seems to me like all of you are comfortable with that, from what I can see in the chat. Let me give you a slight variation of a Pythagoras question. Here is, it says in this question, calculate the area of this triangle. Now, and it gives you 4 different options. Now, in order to do this question, you actually need to know a formula for the area of a triangle. Does anybody know what the formula for the area of a triangle is? Because that will help you. Maybe you can unmute yourself and come on the line and just tell us, okay, David, I'm going to unmute you. Do you know what the formula for the area of a triangle is?
Yes, sir. Is it not half base times height?
Okay, so half base times perpendicular height or height. That is a fantastic clue, David. Thank you so much for your help. Now, using David's clue that area of a triangle is a half base times height, or it must be perpendicular to the base, can you work out which of these 4 options is correct? Calculate the area of this triangle. I'll let you guys try and figure that out before I say anything. So I think it would be a good idea to work out what this length of side is. And then once you've worked that out, what else can you work out? That would be my advice to you. So I'm going to call this side, I'll just call it X. And then if I did that, I know that Pythagoras could help me work out the first bit. So what would you get for the unknown side? That's the first question. So okay, so I get my unknown side as 24. And if I get my unknown side as 24, I then can use those two things to find the area of the triangle. I see some answers coming in. So guys, keep those answers coming in. So a half, so the area is a half times the base. So I'll say times 7 times 24. So think about that for a moment. And you should get 0.5 times 7 times 24. And you get 84. So take a moment, guys, to look at that question. It's A, according to me. So 84 centimeters squared. So the first step was to figure out what this unknown side was. And then in order to figure out the area of this triangle, I had to go a half times the base. And the base was 7. And then the height we worked out was 24. Okay. Give me a thumbs up in the chat if you understand what I did. And you feel like you understand how this is almost like applied Pythagoras. So,
Mr. S,
yeah.
your internet is a bit unstable.
Okay. Is it a bit unstable? And now? Is it any better? Okay. I'm going to move on there.
Yes.
All right, guys, we're gonna do a little brain break a bit earlier in this lesson. And so what I want to do now is we'll take a little brain break. So I want everybody on their feet, and I'd love you to turn on your cameras so that we can see you. And all we're going to do is we're going to pretend we're at Virgin Active and we're at a class, and we're just going to roll our shoulders. And we would love to see you participating. And Label is going to help me identify who would most likely be a gifted aerobics instructor in future. And so let's just stretch it out. And then who looks like they are giving it their all? Achuma is looking pretty good. Who else? Turn on those cameras, guys.
I can see Lucidi. Atrima, come on, guys. Get in on this stretch.
Know your brains. You guys, you know you want to. You know you want to. You want to just, it's been a long day. You just want to stretch it out. And your brain will thank you for it, I promise you. You've probably done 25 minutes of maths. And it's important that your brain gets a break before I start throwing some new stuff at you. Okay, quickly, let's do a little brain break. So our veterans will know how this works. Can you solve what a peach plus an apple times 11 gives you? Your Cameron must be out for the day. I'm sure he'll be back on Wednesday. Okay. Okay, so Dawn, I think I'm with you on the 3 for the apple. Because 3 times 3 times 3 is 27, so that's fine. What else can we do? What do we have there? So lemon is 2. Okay, I agree with that. Yes. And now the peach for the orange. So you've got 6 times something is 96. And so I think that something has to be 16, which means I agree, guys, the orange is 4. So what is the final answer going to be? Because of BODMAS. Okay, yes. It's going to be, so 4 plus 3 times 2, and that's going to be 10. So 6 plus 4, it's going to be 10. Okay. Awesome. Well done. That was a little bit of an easier one, I think, on the whole. So let us now go to grade 10 trigonometry. And in this particular case, we're going to focus on right angle triangles. So right angle triangles, and we're going to deal with, I think a lot of you are familiar with this. So it's just to check that the tools are all ready to use. In a right angle triangle, we talk about a reference angle, and this would be the opposite, hypotenuse, and adjacent. And we can use these trig ratios together with our calculator to help us find unknown sides. And so I want you to try and find for me the unknown side A using your knowledge of trigonometry. If I need to go into more detail, please raise your hand and I will gladly do that. But I think most of you can just give this a go straight away. So how do I find, which of the 4 options is going to be the length of the side A? Okay, so we have a lot of options coming in, which is A. And so we would say in this question, this would be O, this would be H, this would be A. I'm going to choose the trig ratio that involves A and H, which would be cos. And so we'd say the cos of 31 would be A over 16. And then we'd bring the 16 across, and we'd get 16 times the cos of 31 is A. And let's just make sure that we agree on this. I get A, 13.7. Okay, so that's your first little check that you can do this to find an unknown side. Looks okay to me so far. So I'm going to move on to the second example. I want you to try and find the value of, well, I want you to find the option that matches the value of M. So you're given 4 options, and because it's a right-angled triangle, you can use trigonometry, so SOHCAHTOA, to help you find these an unknown side. Off we go. Can you find me an unknown side? Okay, Abenejo, it's got an answer coming in. Who else has an answer yet? Ask yourself, in terms of trigonometry, this would be the hypotenuse, this would be the opposite, this would be the adjacent. So what ratio is going to involve the O and the H? And then how can you write that out? How can you write that out? And then if you have a question, don't be afraid to raise your hand, guys. This is a perfect time to have a chat if you want to discuss something or just confirm something. Okay, quite a few people are getting their answers in. So let's think about how we would start this. I know I would write the sine of 50 is O over H. In this case, the O is just the letter M over, and this is going to be 6. So I've got that bit. And now what I want to do is I want to get this M all by itself. And the way I'm going to get the M all by itself is I'm going to move the 6 across. And so I get, if it's divided by 6, I times both sides by 6. I should get 6 sine 50 is M. Now, which of the options is going to be that? So 6 sine 50, to me, that looks like A. So the answer would be A. All right. Guys, just give me, if I'm going too fast, give a thumbs down. If the pace is fine, give a thumbs up. This is really important that I know that you've got these tools waxed, but I don't want to go too fast if that's the case, but it could be that you are completely comfortable and we can just keep checking off our tool list. Okay. Okay. Let's do one more of these and then we're going to move on. So I want you to find me the length of side A. And again, we're looking for the length of a side in a triangle. See if you can do that one over there. So always start, when you're solving for an unknown side in a right angle triangle, start by labeling your sides. So this will be O, that would be H, that would be A. Now, I always want the ratio that involves something that I know, so it's the A, and this is going to be this thing that I want to get to know. So what trig ratio involves O and A? That's my hint to you. Okay, so in Ndile, I agree, it's tan. So it'll be tan of 15 equals, and that's where we're going to go, it's going to be A over 21. But now we still need to find what the value of this A is and choose the option down here. And all we need to do is bring that 21 across. And so then we're then going to get 21 times the tan of 15 is A, and 21 times the tan of 15 is going to be 5.6. And so it's going to be B. All right, fantastic news. You have mastered the ability, given a right-angled triangle, to find an unknown side. And I could do 3 or 4 more examples with you now, but essentially once you've got this basic skill, it's fine. You can build on that. However, there is another situation where you're given a right-angled triangle and you have to find an angle. And that is the situation I want to look at now. So in this particular question, you'll notice that I'm given 2 sides. So I'm given the hypotenuse and I'm given the opposite. And they want me to figure out what's called the reference angle in a right angle triangle. I want you guys to think back to grade 10 and maybe even earlier in the year if you're with Watobe, and ask yourself, how do I figure out what this angle is? It's a slightly different process. And I will do it for you now, but I want to give you the chance to try and do this first.
Mr. S, are you aware that your camera is a bit...
No, I'm not. Sorry. Is it focused on me now?
Yes.
I think that was from all my enthusiastic stretching.
Oh,
So thank you for that. So I said to you guys earlier in the lesson, it was all about finding sides and angles. And in this case, ask yourself what trig ratio involves O and H. And I think you can say the sine of X is just going to be 7 over 10. Now, what you need to do in this question is you need to get the X all by itself. And so what you do is you use something called inverse sine or arc sine. And so you type into your calculator, you say, I want the sine minus 1 of 7 over 10, and that will give me my value of X. And what that's saying to the calculator is, I'm giving you the ratio of 2 sides. Please give me back an angle. And what you should get is you should get 44.4, which will be option B. Now, what I want to point out is the subtle difference. When you're solving for angles, you're always going to have this inverse trig function, right? With this little -1, and you're giving it the ratio of 2 sides. So that's always going to happen when you're solving for angles. And it's just good to separate the idea of when you're solving for sides, when you're solving for angles. So the confirmed answer is B. Let's try another one. I want you to find me the size of that angle X there. And I'm not going to give you too many hints on this one. I think you're going to fly more solo. So on Ntokozo, you're on the right track, I think. So that would be O, that would be H, that would be A. Now, what trig ratio involves O and A? Oh, wait. And of course, I don't know if I agree with you, because what trig ratio involves O and A? So what you see is O and A involves tan. And so I think what you're going to do is you're going to write tan of x is equal to 10 over 8. And how do you work backwards from that point? Okay. So Lati, have you got the answer for that one? You said B. Who agrees with that? So let's have a look. So we have tan of x is 10 over 8. But now in order to get x, which is this angle, I have to use the inverse. So I get tan minus 1 of 10 over 8. So shift tan 10 divided by 8. And I'm going to get 51.3 degrees for x. And so my final answer would be C. Okay. So again, give us an indication in the chat. Is it feeling very easy? Like, are you feeling very comfortable with that? Thumbs up and thumbs down if you're feeling a bit in between. And we'll do one more. And if you've got this, then I'm ready to move on. Okay, so we're almost there. Notice how we're finding the angles at this point and the slightly different process we're using. Okay, and take a screenshot now if you have to. Okay. I want you to find the size of the angle X in this question. So again, over to you guys. In fact, you know, guys, what I'd love, if someone's willing to, I'd love it if someone would come online and tell us how to do this one. Nizole, that's the process of learning. You just have to you just keep improving, and when you look back, you go, "Oh my goodness, how could I have done it that way?" But that's true in so many areas of life. So if somebody is willing to be brave, I'd love it if you came online and helped me with this question.
Mr.
Maybe
S,
put your
we
hand
have
up.
a question
Yeah.
from Dogozo.
Okay, and Gozo, will you want to unmute yourself? So you can just unmute level, or I'll do it now, but yeah, there we go. And Tokozo, what's your question? You want to go ahead and ask your question? Hello, Ntokozo. Can you hear me? Okay. The quality of the audio is quite bad there. We'll take the question if we can. I heard the hi.
I thought we were going to do the equation.
Can you do it?
No, I want to do the equation.
Ah, okay. Go ahead. Talk me through it.
Yeah, equation.
Okay. I'm going to do it this time for you because I think the sound is a bit dodgy, but thank you for the effort, man. Okay. So for this question, cos of x is 5 over 8. So we've got, what have we got? We've got cos minus 1 of 5 over 8, or inverse cos. And what do we have? So shift cos. We should get for x 51.3, which is A. And I see the majority is definitely getting A in the chat there. Okay. Let us have a look. Let's do one more. Okay, this is a bit more words, guys. We're throwing a bit more words at you this time. So we've got in triangle PQR, you are given that PQ is 12.3. So PQ is that length there. And you're also given that PR is 13. And what they want you to do is they want you to find what this angle over here is. So over to you guys. What is the angle theta? That was nice and quick, Sarah. Who else has the answer for that one there? So think about the fact that this is O and that's A. So I think we're going to write the tan of theta is 13 over 12.3. And so then when we get inverse tan of 13 over 12.3, we are indeed going to get around 46.6. In fact, I even have the answer here. So let me blow it up for a second. Oh. And so you should get, if you're using 2 decimal places, 46.58 degrees. So I didn't actually specify in this question, Sarah. So normally exams are 2 decimal places, but sometimes they are 1. It does depend on how it's worded. All right, so I think that if there are any students who have questions about how to find sides or how to find angles, please do raise your hand. Otherwise, I'm going to give you a preview of the next lesson. And we're going to talk about something from grade 11. So are there any questions? Okay. So guys, as we look at grade 9 and 10, a lot of it obviously is just the stuff that we've done today. But what about some new things that we are going to do going forward? And so one of the things that I want to talk to you about is something called the area rule. Okay, and all I'm going to do in this particular last example is show you kind of why we need some new tools in our toolkit. Okay, so if I gave you this particular triangle here, and we looked at it, and I said to you, like earlier in the lesson, I said to you, find the area of a triangle, and you guys could do that, right? And what was the formula that David gave us? He said the area of a triangle is a half base times the height. But now what happens if grade 11 comes along and gives you a triangle like this? And this triangle that I've given you, how would you find the area of this triangle? Can we still use the formula that David gave us earlier in the lesson that we learned in grade 9 and 10? Or what are we missing for that? Would anybody like to come on the line and give me a little bit of a, what's the thing that's missing that we need if we're going to find the area of this triangle? Anybody feeling brave, like they want to pop on the line? The height. See how you're quite right. So if I knew what the height, let's say I said that the 6 was the base, then I need to know how high, what's the perpendicular height of this triangle? That's if we only used grade 9 and 10 tools. So the problem is we only have a side, and then we have another side, and then we have an angle in between those two sides. Now, how are we meant to find the area of a triangle given that information? And so in the next lesson, what we're going to do is we're going to explore something called the area rule. And just to give you a little preview of what the area rule says, the area rule says, if I have two sides and an included angle, like if I wanted to solve for the area of this triangle, all I need to do is say a half times the one side. So what is one of the sides here? It is going to be 6. And then we're going to times by the other side, which is 5. That's all very kind of like, okay, why am I doing that? And then you times by the sine of the angle in between those two sides. So in order to find the area of a triangle where you don't have the height, but if you do have the length of two sides, all you do is you times the two sides, you times by half, just like before. You then times by the two sides that you have, and then you times by the sine of the angle in between those two. And so just to finish tonight's lesson, can you guys work out what the area of this triangle is going to be? So I want to see using, I've just told you about this rule. It's completely new, and we're going to work on it in the next lesson. But what would the area be of this triangle if I'm telling you the truth, which I promise I am? It's a little bit like magic. Like, how does it even work? But for now, we're going to take it on faith. So work out the area of this triangle for me, then pop it in the chat. So we go 0.5 times 6 times 5 times sine of 78. And we should get the area is 14.67 centimeters squared. Or they weren't actually centimeters here, so it's just going to be units squared. So the new tool that I've introduced to you tonight, and I just snuck it in here at the end, is that if you want to find the area of a triangle, not only do you have the grade 9 and 10 stuff, using some magic that I haven't really revealed to you, you can use trigonometry to help you find the area of a triangle by using this formula, a half times one side times the other times the sine of the angle in between. And so that's where we're going to leave it for tonight, guys. So